You know, whether you're in your kitchen or we're talking about huge factories, we are constantly sorting and separating things. It might seem kind of basic, but there's some really fascinating science hidden in these everyday tasks. So let's dive in and uncover the methods we use to bring a little order to our mixed-up world. Come on, I am willing to bet you've done something just like this. You're about to eat, you see something you don't want, maybe it's a chili, maybe it's an olive, whatever, and you just pick it out. Well, that simple little move, that's the most basic form of separation, and it's the perfect place for us to start. But of course, it's not just about picking things out of our food. I mean, think about it. We separate tea leaves from tea, we get butter from milk, we separate seeds from cotton. We do it to get rid of stuff we don't want, sure, but also to get the useful stuff all by itself. Separation, it turns out, is a really big deal. It's fundamental to how we use pretty much everything. Okay, so let's start with the basics. The methods that are really intuitive. The ones that just rely on our own hands, our eyes, and, a little bit of muscle. This is like our beginner's toolkit for sorting the world. So this is what we're talking about. Handpicking. It's absolutely perfect when the things you want to get rid of, like little stones or bits of dirt, are easy to spot and big enough to actually grab. It's super convenient, it works great, as long as you're not dealing with a mountain of the stuff. Right, exactly. Handpicking has its limits. Can you imagine trying to pick out tiny seeds from thousands of stalks of wheat? Or trying to separate a cup of salt that's been mixed with a cup of sand? No way. It would be impossible. So when the problem gets bigger, we need smarter, better techniques. And this is where we get a little more forceful. This is called threshing. It's basically the process of beating the heck out of stalks to shake the grain seeds loose. You just can't pluck them one by one, so farmers figured out, hey, let's just whack it. This can be done by hand, by using animals, or these days with massive machines. Okay, now this next one is just brilliant. It uses nature as a tool. It's called winnowing. So after you're done threshing, you've got this mix of heavy grain and really light husk. So what do? You let the mixture fall from up high, and the wind just carries the light husk away while the heavier grain falls straight down into a nice clean pile. So simple, but so smart. And this brings us perfectly to our next method, sieving. When you've got a mix of things that are different sizes, a sieve is your absolute best friend. The tiny, fine particles fall right through the holes, while the bigger stuff gets left behind. You see this everywhere, from sifting flour in the kitchen to separating pebbles from sand on a construction site. All right, let's move on to our next toolkit. Sometimes the stuff you're trying to get rid of is so fine that even a sieve won't work. For that, we turn to a very powerful, very common tool, good old water. Think about it. When you wash rice or lentils before you cook them, you're not just getting them wet. You are actually performing a separation. All those tiny little dust and soil particles are way too small to handpick or sieve out. But when you add water, something really clever happens. It's actually a cool two-step process. First up is sedimentation. You let the mixture sit for a second and the heavier rice grains all settle to the bottom. Then comes decantation. You just gently tilt the bowl and pour out the cloudy water, which carries all those lighter dust bits away with it. You could try to decant your tea, right? Carefully pour the liquid off the tea leaves. But let's be real, you're probably going to get a few leaves in your cup. That is why filtration, using something like a tea strainer, is so much better. The little holes in the strainer let the tea through, but they stop the solid tea leaves cold. So far, we've separated solids from other solids and solids from liquids. But what about the trickiest challenge of all? How do you separate something that's completely dissolved into a liquid, something that's become totally invisible? Well, for that, we need to turn up the heat. This is the classic puzzle, isn't it? Once you dissolve salt in water, it's gone. You can't see it, you can't filter it out, and you definitely can't pick it out. The salt and water are a solution now. So how in the world do you get them apart? Out in the real world, this is how it's done on a massive scale. They collect seawater in these huge, shallow pits. Then, the sun provides all the heat needed, and slowly but surely, all that water just disappears into the air, leaving something very valuable behind. And that process is called evaporation. By heating a solution, you can turn the liquid, in this case water, into a gas or vapor. But the solid that was dissolved in it, the salt, can't turn into a gas at that temperature, so it just gets left behind. And that is how we get salt from the sea. But wait a second, what if you wanted to keep the water too? Well, You can. If you capture that steam and cool it down, like by having it touch a cold lid, you can actually reverse the process. This is called condensation. The water vapor turns right back into pure liquid water, now completely separated from the salt. Okay, deep breath. We've learned about handpicking, sieving, decantation, filtration, evaporation, and condensation. We have a whole bunch of tools now, so let's see if we can combine them to solve a really, really tough separation problem. You ready for the final boss? And here it is, the ultimate challenge. A simple-looking mixture of sand and salt. You can't handpick them if the grains are the same size. A sieve is useless, and winnowing won't work. So how would you even begin to separate these two solids? Well, the trick is to use their different properties. First, you add water. The salt loves water. It dissolves. The sand, not so much. Step 2, you filter the whole concoction. The sand gets caught, leaving you with salty water. And we already know how to solve that. Step 3, you evaporate the water to get the salt back. And hey, if you want, you can even do step 4 and condense that steam to get pure water. Boom. A perfect multi-step separation. But hold on, there's a little mystery here. A character from our source material, Paheli, tried this exact same experiment. She followed all the steps, but when she was done, she found that she had only recovered a tiny fraction of the salt she started with. So what could have possibly gone wrong? And the answer, the reason it all went wrong for her, lies in this one key concept: a saturated solution. See, there's a limit to how much stuff you can dissolve in a liquid. Once you hit that limit, the solution is saturated. Any extra salt you add after that will just sink to the bottom. Paheli's problem was actually really simple. She didn't use enough water for the huge amount of salt she had. And what's really cool is that this limit isn't set in stone. If you heat up a saturated solution, you can actually dissolve even more stuff into it. This also explains why, water can dissolve a ton of sugar, but maybe not as much of something else. Different substances just have different limits. Okay, so let's end with a final challenge for you. You're making lemonade. You want it to be really sweet, and you also want it to be ice cold. Knowing that temperature changes how much sugar can dissolve, should you add the sugar before you add the ice or after? The answer is right there in the science we just covered. Think about that next time you're in the kitchen, because the science of separation is absolutely everywhere.